Questions, please come forward first.
So thank you everybody, the speakers, also the audience. So we expect a more active participation in this session, and of course we apparently do not have any time constraint at this moment. To me, actually, one question about the railway bearing remain unanswered. That is, what exactly our developments coming to magnetic bearings, I think we have to identify the areas where we expect immediate production or industrializations. Coming to aerospace grade bearings, I understand there are a lot of hybrid bearings in terms of ceramics coming. But I know ceramic is used only for rolling elements, rollers or the balls. But ceramics are not used in races or even cages. So probably if anybody has 3 questions I have raised, people can respectively try to address. So let us look into the railway bearings. What exactly the recent developments from low speed, average speed train to high speed train.
Yeah, I want to take out this question about the evolution of railway bearings, especially TBU from lower speeds, maybe around 120 to 150 to 200 kmph. So what evolution has been done on the bearing side? What researches has been done? So that is what I understand the question is. And the development side from the bearing manufacturer, especially if I want to speak about the SKF side. So mainly it has improved about the grade of steels. We have migrated from the quality of steel from which has a higher performances and can sustain for higher temperatures, as well as to have cost effective measures, because the expectation is also on higher performance with the lower pricings. So that we have done on the steel grades. We have worked on different steel grades, as again the recipe is about and it's in the not in the parameter of standardization, which needs to be maybe in the course of time. And the second one is about the through hardening as well as the case hardening. So these are the 2 parameters where we play bearing manufacturers for the rollers, which gives an optimum performance increase. And lastly, about the grease. The greases are been given a much importance nowadays, which can have good capabilities, and they can sustain at a higher temperature as well as higher load conditions and a higher life. So with that 3 parameters, so now we are migrating from 150, 130 to around 200 kilometers per hour. But of course, the expectation of high speed trains, which is like the corridor which is running within benchmark with other countries. So again, this type of bearings, the high speed bearings, needs to be worked from product portfolios of bearing organizations. This is my view. Maybe other sir can add.
Now, in addition to whatever Gurraj has told, so what we did, one thing is we changed the cage, from steel to polymer cages. So that also helped. And in addition to that, you have seen I showed the Ecoton seal, because as the speed increases, your friction will be much higher. So we have to reduce the heat generation inside the bearing. So what we did we had this Ecoton zero torque seal, in which you can go much higher speed, even though, because speed will not matter when there is a non-contact. So any speed you can go, even 350 or 400 kilometer. Usually seal is element which is contact type. So that we worked and we developed this Ecoton seal. I think you have seen also the 100 cart, if you pulling 1 year, the saving, that is a huge saving. And also, no, second thing is, the temperature side. So, there is no limit from the seal perspective. So, and then third thing, as he has told, on the grease side, so we tried with the different grease, maybe SHC 100, SHC 220, and by putting different quantity of the grease inside the bearing, we measured the temperature. So where we get the optimum temperature, what should be the optimum quantity of grease? That is very important. Now we have seen huge improvement when you reduce the grease, maybe 10, 15 grams, because that makes a lot of difference. So we have done a lot of R&D on that front. So now we are able to run 300 plus kilometers on our bearings.
One point I want to just add in addition to what Mr. Rai has told about the refurbishment. There was one question about the refurbishment where he was telling he has not heard of. Railway bearings are the one who are in need of refurbishment. We provide around 2 additional cycles of refurbishment where the life cycle can be extended up to around 0.6 million kilometers approx. Yeah. Yeah. Double the life.
No, what we do, once they have the bearing, we get the bearing back, and then we disassemble. Anyhow, cage is useless. We will throw. We have to press a new cage. Then we inspect, both inner race and the rollers and the cup, and we see whether any, wear marks or anything. Most of the places, because of the very clean steel, we don't see any issue. Marks. Then we do a grinding, and then we set, the bearing. No, balls, nobody will do, because ball bearings, first thing we don't use much. No, roller, we replace, because roller, not a big cost. Maybe few rollers you have issues, so throw those rollers, use a new roller. No, new grease, new seal. So it is a brand new bearing. So Indian Railways does, everything every time, after maybe 3 years, 1 million kilometers, they send, that is a big business actually. Yes, but you talked about aerospace refurbishment. I don't want to get into aerospace refurbishment because the reliability required is 100%. So we never know anything on that. No, anywhere you should not do. See, because even if you see landing wheel, they use our bearing in the, almost 95% of the aircraft as a Timken bearing. What they do, they, after that they throw that bearing, they don't use that. Because you never know, because if something goes wrong, all the people on the flight, will be, Yes. Even a small abrasive, if it comes out, damages the whole bearing. It has happened once for us. In shop testing we were doing, night riding, peeled out, damaged the total bearing. Some abrasive particle came out and it totally damaged it.
Aerospace is altogether a different ball game. But anyway, I had yet another question. Like, is there any special coatings or surface engineering now appear for bearings? And I think this is more relevant if we are thinking of hybrid bearings, where we use rolling elements and metallic bases. So, Mr. Vangelis would like to highlight that hybrid.
Actually, we introduced hybrid bearing way back in 2000 when we replaced metallic rolling element, that is ball, into as ceramic, and it has performed well. And I heard there are other aero engine global, they are using ceramic all, even races also, but I don't have full information on that. But after using ceramic, it is performing very well.
I would like one person is sitting there. Yes, with Solai Raju. I think you have also thinking of working on hybrid bearings. Can you highlight something on who are the manufacturer of the ceramic balls and what are the ceramic balls you are using? And what is the status of hybrid bearings usage in India now? You'll give you a mic. You can sit in your chair and tell, no big issue.
As on date, actually, industrial bearings like ceramic ball bearings are being used. I mean, balls. But in aerospace application, people are not to that level because the research are on like you. But advantage in aerospace application because speed, the DN number in which it operates, it's more. So that has got a unique advantage, and the temperature of operation also is there. So for that, ceramic balls have a better characteristics in its operation. Now, otherwise in industrial application, normally the ceramic ball or hybrid bearings are being used for the motor electrical applications. So, but when in aerospace, to the aerospace sector, these grade of balls need to have a higher bearing accuracy. Like we talked bearing ball grade as 10, 5 and 16 and so on. So for aerospace application, as the precision class is requirement is higher, the balls also should have a higher precision class to the order of grade 10 at least. So to that class accuracy of balls, I think to my knowledge, nobody manufacture in India, in the country, and we are trying to establish some of the process through CGCRI, CSR. Some work we have started. We are planning to have a silicon nitride in the balls.
Ceramic is manufactured. They are manufactured balls. You have to do this.
Oh, we have many.
I think there is some escape. You have somebody, some hybrid bearings in operation at this moment?
Yeah.
Please, let us know.
Yeah, Harsh, can you give me my mic? Not working?
So from a Schaeffler point of view, definitely there are some of the applications where we have already initiated the hybrid bearings. If I give you the example with respect to the electric motor application specifically, the present trend, what all the manufacturers what we are using it are the insulation of the outer ring is there, because we have to, the requirement is that the bearing, the current should not pass from the outer ring to the roller and to the inner ring. Otherwise there will be a fitting marks will be there, and then the bearing will be destroyed accordingly. So now the upcoming trends, what we already have it, that in order to have the specific insulation on the bearing itself, we go for the ceramic rollers applications, so that we change the rolling element from steel to the ceramic, so that we can discontinue the flow of the current from the bearing itself. So this is one of the application already in the. The races remain the metallic only. Only the rolling element will be changed. No, it is not so. It is not so that it is higher. So some of the applications we already initiated. Some of the more analysis we are already going through it, for which different applications. But the concern with respect to the wear of the races will be more. It is not so. We are already giving the load carrying capacity and the limiting speed as per the required specification. It's almost equivalent to the what we are using with the steel only. So it's not, we are not deteriorating either the load carrying capacity nor the limiting speed of the bearing also.
See, what we are doing, particularly on the ceramic balls, when you are using, your speed will be much higher. The load will be much lower. So once the speed is higher, load is lower, then we don't see much wear on the inner rings. I have not seen any bearing with the ceramic inner or outer. So, but all the machine tool, wherever you have high speed, grinding and all, people go with ceramic ball bearing. So we have full range of ceramic ball bearing. And also now in railways, lot of traction motor bearing that comes with ceramic because of the insulation part. Because if you use a ceramic, that will not conduct, non-conductive. So that serves that purpose.
for Vande Bharat. Yeah.
Regarding the whatever you told regarding the modifications for the high-speed railway, in terms of DN, how it is closer to the aerospace bearing in terms of DN?
D, DN is not like aerospace bearing.
Okay, it's not.
Because if you take, for example, 200 kilometer per hour speed, 200, I think the wheel diameter is around 36 inches. So take 1 meter. So for one revolution, 3 meter it runs. So for 1 minute,
But
1 minute.
they're
will
not
be-
comparable.
No, it is not comparable. So speed maybe like you have seen our test rig can run maximum 3000 RPM, whereas your engine may run at 20,000, 30,000. It is not at all comparable.
What about the, you told about the seal modification, you told about the coating. What about the fitness and the tolerance? Whether you improved on that for high-speed bearing? Or
No, because those are all is governed by these standards.
for high speed, is there any different standard? High
No,
speed?
no, same thing.
Same,
Yes.
same.
From the Tata bearings or Tata Steel, I think you are from Tata Steel. Yeah, you have some recent understanding about recent developments of bearings, or are you trying to introduce any kind of coatings,
Give me the
coating
mic.
for the bearings parts? Yeah, Mike, please.
Just to sum, there have been a lot of discussions on this ceramic bearing. Just like to add, we use a lot of ceramic bearings in the high spindles, which we are using for the raceway grinding. And the life is very good. And as such, there is not much of a, when you use ceramic bearings, should not be too much of shock loads. Otherwise, there will be a problem. And if you see the lubrication part, I think simple oil mist will also be able to do instead of too much of a lubricating or some grease or other applications like that. So that is one part. As far as development on the ceramic, why ceramic balls are being used for that, avoiding the fatigue failures because of the conduction of the current from the inner to the outer. So there are also some requirements also and some developments by the EV segment where insulating grease are being also used. So the ball will, inner and outer ball will be metallic, same normal bearing steel, and they will be using non-conducting grease. These are available. So this is one. Yeah, we had some apprehension that the EV segment will ask for because the product drawing, whatever we used to receive from any of our customer who are in the EV segment, that the RPM will be some 18,000, 25,000 like that. But however, when we calculate on what is the speed which is coming and it will be taking off, the speed will be so high. So when we actually in practicality we went to in discussion with them, then the speed is limited about 7,000 or 8,000 it will go. So it was very astronomically some ambitious, some sort of absurd requirements which were coming in. But yes, but in some requirements these type of things are required, probably some things we need to do. Regarding the coating aspect, yes, we tried out some coating and but results were very encouraging. But for mass production and other aspects, there were a lot of constraints in the, in Proto we had developed with our R&D center in Jamshedpur along with our Tata Steel entire this thing. That was quite successful. But the main problem what we were getting is, like the surface roughness. Okay, while before you coat the thing, you have to be very, very clean, and this otherwise that is because the coat level of the depth of the thing is also detrimental for we are doing it in the ball bearing, so radial clearance is important. So and we cannot again rework it. Once you coat it, you cannot rework it. Those aspects were also there. So there are some challenges for bulk production on that aspects. So but however, whatever we made as a proto this thing, and we also validated on our test rigs, we were getting almost against the normal bearing we were getting about twice or 2.4 times of the life. So those things are there, but not very conducive for a mass production.
Keep it
Yeah.
pending for some time.
Yeah.
Unless the application
but-
makes it.
Right.
More
So I have two questions here. Like one thing, what you had. No,
Only
it was
races.
only on the raceways. Only on the raceways. Ball we were using the normal one, just without any.
Balls can be thrown, no? Balls are rollers. They are such small parts that can be, if something goes wrong, you throw it. They are consumables.
We have worked on, the coating. This is not, this is like, we have different coating, like thin dense chrome, that is on the, bearing. Then aquaspex coating, where you have lot of water, so that prevent from rusting. And then also we have, like engineered surface, where we put very, in maybe in nanometer, on the surface. And then, that will be very hard, maybe 65, 68 HRC. That is on the, raceways as well as on the roller. So wherever, particularly the wind energy, lot of bearing, bigger bearings, we were seeing a lot of damages. So those places, we use this coating and, because that is very slow speed rotate. So, that fretting issue was there. So because of this hard surface, we are able to eliminate that problem.
Yeah, no, they see, when it comes to
graphene-
coatings, when it comes to coatings, coatings can be classified under different heads. There are certain coatings which are very hard and very wear resistance, but they doesn't really reduce the friction coefficient. There are certain coatings which are not very hard, but they reduce the friction. They are self-lubricating kind of coatings.
Correct.
There are certain coatings which might not be self-lubricating, may not be even wear resistant, but they are very much corrosion resistant.
So you are absolutely right. That is the reason I told, this wind energy application is slow speed, but you need a very hard surface because of the fretting. So we are able to resolve that issue, because it is not very high speed.
See, the coating thickness is also very important
Yes,
because once we do the finishing of the races, we do the super finishing, then we do the coating.
Yes.
Now, once you do that, you need that relationship for maintaining that radial clearance. Otherwise, what will happen for the ID and the OD part? In OD, you will be depositing, and ID you will be increasing the quotation. So maybe the you have to generate scrap, basically oversized inners, and then you coat and make it within the tolerance of -0, -6 or whatever.
In
tolerance.
this
Those are
figure
the
also
challenges.
there is another important thing. Coating when you deposit,
Yeah.
majority of the techniques, especially PVD and CVD techniques, thicker the coating becomes, less adherent the coating is. It generates a lot of stresses within the coating itself.
So it
that
should
is
be
optimum
nanometer.
thickness.
Yeah, that is the reason.
Optimum thickness. And if you do very thin coating, that may not serve the purpose at all, eventually. If the coating, if you have the same lifetime, there is no point wasting extra money for putting the coating. So I think there is also another critical
See,
aspect.
graphene is a very good technology which is already well established in Tata Steel. So we also thought of making certain things, but then our roughness and other things were way beyond this thing. We can't, because here we are
Graphene and all
expecting
must be nanometer level.
0.0402. We are not
No,
able to maintain. So,
Actually, this coating technology you have to use to solve the problem, not like your standard product. So
something
you have a problem which you are not able to do anything. This is the final solution. So coating, that's what I told wind energy. No other way, we could have had a harder surface. So that is the reason we went there. But it is very costly, and you can't use for your general application.
There is one coating which is now for quite some time in the scientific field. They call it nanocrystalline diamond films. Now, one of the very important thing about the nanocrystalline material, that is making material nanocrystalline is the only way not only to enhance the strength but also enhance the ductility. But in diamond coating, what is found, even though coating ductility may not be very important to measure, but nanocrystalline diamond doesn't have higher strength than that of the diamond coating. But diamond coating is not able to play a role in such kind of application. Main reason is that its roughness is very high. You cannot have very smooth diamond coatings. Secondly, if you put a diamond coating on any of the part, if you put diamond coating on races, your balls and rollers you have to replace much more frequently than using it. Nanocrystalline diamond coating is one thing which is very tolerant. It is corrosion resistant. It reduces the friction coefficient because all diamond coating has self-lubricating factor. It is also wear resistant. It just optimizes everything. But there are two problems with nanocrystalline diamond. First of all, you cannot deposit it at lower temperature. As you said, after finishing, After finishing, you cannot expose it to 500 degrees centigrade. That's another problem of using it. Second thing, the nanocrystalline diamond coating has not come in the commercial level where you can really coat a large area. So there are constraints with everything.
See,
Anyway,
if you are talking about the surface finish, for that coating may not required. So the cheapest and the best process is isotropic finish. So put some chemical and you just tumble that gives you 0.1 micron. So that solves your all the lubrication related issue. So
okay,
instead-
I will now move out because one of our speakers has to
So
leave
I
shortly.
would like to understand, various application for this magnetic bearing.
Yes.
in the current-
So we are now graduating to magnetic bearing lenses.
Quickly, I'll respond to that question.
Yes.
Yes, missed the slide. So, application actually, based on our experience, as of we understand, very specific area. So far, people are trying to use magnetic bearing. Say nuclear power, what we are working with them. So that is one area. And the high-speed rotating system, particularly in aerospace application, or in automobile also turbocharger, they are rotating at very high speed. Those areas, hybrid magnetic bearing, passive magnetic bearing, even some oil bearing, aerofoil bearing, combination can be used. There are even process industries or I think in oil industries, there are slurry pumps and those areas also people are trying to implement a magnetic bearing.
Is there any limitation on the RPM? It cannot operate at 5,000 or 7,000 RPM?
No. In low RPM also it can
So
even
why it
wind
won't
energy.
be applicable in automotive segment?
Initial cost actually. Cost will be the main factor which will stop it. I mean, automobile you may be talking of 100, 200 rupees or 500 rupees bearing, but which is not possible to develop magnetic.
But are
bearing for
these
that.
hub motors which are being put in the rear wheel of EVs, are these not
I have not come across to that.
those are all with bearing.
Yeah,
no, those are not
conventional.
with bearings? Those are not.
No, I understand there's a lot of potential of magnetic bearing in many areas.
Yes.
But what is the one government of India should target that we should immediately put magnetic bearing?
Energy
some
sector,
identified
energy sector, wind, energy storage flywheels, their potential area people can work on that. Yeah, that way.
So maybe BIS also can think which way we can pursue government to bring them.
Because we are working
Precise.
more towards energy storage system.
Actually, I got one request for that flywheel. So that weighs 22 ton, the flywheel, diameter is 6 meter. So he asked me to select a bearing for that. I told no, I don't have solution. So magnetic bearing is the best solution for that.
Yeah, that can be looked into that.
Yes.
We identify
Yeah.
one area.
Yes.
Professor Tiwari also.
I would like to respond to him.
Can I request I can leave this moment?
Just
Sorry,
before you leave, I just want to make a small announcement kind of thing. That is, BIS is planning to have some research also in these areas. There are many areas I have found. I'm not sure. It is only my perception. Please do not accept that or think that this is the area we should go. It is only my perception. I'm thinking we should make a document, very well document, in terms of application of magnetic bearings in strategic applications. Magnetic bearings for strategic application, and the people who are working in magnetic bearing, we may take about a 1 year of time, or maybe if necessary we can extend it beyond that level. And BIS can give a small funding in terms of, suppose we have to meet somewhere else, BIS can probably sponsor for at least for the government servants the traveling cost. The funding from BIS will be only in connection with the travelings. Other contingencies, traveling and little bit contingencies, which should be very limited. BIS can think about it, and also that this sounds to be a proper. Okay.
Apologize for my absence. I was enjoying the talk. Thank you so much.
Thank you, sir. Regarding the, I think, motor which you are talking about for E, so there are now bearingless motors. So they combine the magnetic bearing and the motor together, so that there is no physical contact between the wheel and the, I think, the bearingless motors are also, I think, bearingless. No, circular.
Linear motor is
Not linear, circular. it can rotate. Yeah, bearingless motors are available. And other application is it told regarding the flywheel storage system. So there are two things in that. One is for charging, charging stations for the so because you can store the energy in the kinetic energy form, and then whenever some vehicle battery has to be charged, you can use this kinetic energy, convert it to the electrical energy, and that. But now even in the vehicle also, people are trying to put this kind of kinetic energy, and it can be converted to electrical energy, and the motor can take that energy. So there the application, you require high speed, because the rotor you would like to have small there, but speed high, so that you can store the kinetic energy there. Yeah, so that is we wanted to supplement.
Sir, one question for the aerospace bearings. Which kind of bearings can be taken up as the first stepping stone in standardization? Maybe Gonzalez sir would like to answer this, because we are talking about airframe bearings, but what could be more economically viable and useful for to standardize in the aerospace bearings?
Deep groove ball bearings are very extensively used compared to other bearings. So maybe that is I would like to ask Ulay Raju.
Because that finds a lot of application.
Yeah.
That can be taken up as a first front case development, because then comes cylindrical roller bearings are being used. Then if, in the engine application we have a split 3-point contact bearings are there. So widely deep groove ball bearing DGBB can be taken up. Only in the when it comes to aerospace application, the precision class is the main thing. So with that consideration, we can start at DGBB. Okay, sir.
Yeah, I think I also agree. Think ball bearing, cylindrical bearing, and the split inner ring. These are the three I think extensively
Yes,
used.
sir. Yes, sir. Sir, and one more question.
I think we are planning to have a meeting.
Yes, sir. Yes, sir.
After we have this meeting, probably we can give a better answer to BIS about this. And my understanding is we should only, for the time being, for aerospace grade bearing, we should only concentrate on all the bearings which are made of M50. M50
Yes, sir.
still. After that, probably we can graduate to M50 nil. Then we'll think of rest. For the timing, little is enough. I think M50 itself is quite extensively used. What are the varieties? But before that, I think we need to have that meeting
Okay,
to
sir.
know
Fine,
and
sir.
understand which part of the engine we are using, what kind of bearings, and what is the material we are using. It has to be substantiated by why we are using this material and this kind of bearing for this kind of
Yes, sir. Yes.
locations. Understand my major objective of that meeting, that will be, I would prefer to have it in Bangalore. Maybe I will insist on GTI or AD to organize
Fine, sir.
it,
Fine, sir.
but we'll have it as early as possible. Okay.
Yes, sir.
And but then there is one more thing, if anybody can address this. I think one of the important issues of aerospace grade bearing is to keep the bearings at a lower temperature. So temperature control in the system, how it is done, and what are the new methods or systems are coming. Anybody can answer. It is, I'm not insisting on.
Sir, I'll say a few points on this. Actually, all these aerospace bearings are mostly like a vacuum packed and with the preservatives. So basically, these bearings are mostly of steel, and the cage will be of bronze or again steel category. So it can be stored in a normal room temperature itself. There won't be any specific requirement. Okay, sir. Okay.
Aerospace engine operates at 1500 degrees.
Fine, fine, sir.
But bearings are not.
That actually, that as sir told, yeah.
Yeah, that is that's why in an engine, aero engine, lubrication system is very important. That's why we have like a design of pocket, like a CFD analysis will be done. How that there's a cooling system is there, and oil system also. The lubricating oil, there is a oil cooling system is there, so that will be cooled. So it's always that the system will be in place. Like a temperature will not be go beyond the.
So the lubrication is
Yeah.
a lubricant or it is a coolant?
Both.
kind of lubricant?
Yeah, it does that elasto aerodynamic that film, as well as it is a coolant. So that works like that. So that is that parallel. That's why, you know, in engine development, all the systems run parallelly. So when we select a bearing, that lubrication system also they will work. Lot of design activities will be done. So only when everything converges, then only is.
Separate out civil aircraft and fighter. Civil aircraft, fortunately, doesn't operate at 1500 degrees. I think the operational temperature of the engine is some 1000 degree or 800 to 1000 degree. Maybe the cooling system which is available today. Yeah. So if the engine is operating at 1000 degrees centigrade, it can be less than 300 degrees. But the fighter is supposed to operate even beyond even 1500 degrees. There are a lot of designs that coming to operate. So if you are operating it at 1500 degree, engine is operating at 1500 degrees. Whether we have efficient cooling system, it will keep the temperature to 300 degrees centigrade. And that's why M50 and M50 which can operate at 500 degrees centigrade even. And but the advantage is the fighter aircraft, it don't operate for down both of the bumper. So that's probably one of the optimization. But I think this is another area where we need to have enhance our knowledge and understanding of how and engine.
Regarding the, I think I will add to this. Even I think some of the requirements are where a very short life of the bearing is required. So there even the fuel is used as a lubricant and the cooling both. Yeah.
Well cooled.
Yeah.
These actually very high quality fuels are used in aircraft. But see, as far as temperature is concerned, right, whenever we do some failure analysis of bearings,
Warranty issue or some failure thing has come, okay, so there is a standard by the metallurgical this thing whereby, you know, color of these races can also speak about till how much temperature and how long it was there. So generally about 2 hours at that 400 degrees centigrade it has to sustain, then that color changes. So whether it is reddish, bluish, and that, so that template we see and check out. So we can tell definitely the customer, we tell okay, it was actually some lubrication failure, otherwise this type of, you know, temperature rise should not have happened. So that is also a thing which is already there in the failure.
No, I think no, here you should be very careful. Sometimes no, because of no the lubricant, you will have stain like thing no on the surface. So best way is no see the microstructure of the metal by cutting, by seeing the the transformation of the cell. So we do that, but just by seeing the surface we never, because there are so many reasons no maybe. So best way is no take a section and see the change in the structure. So because if there is any the martensite or right, those changes will happen.
When people do failure analysis, they do all sectioning. They must be doing. He is trying to tell some shorter way, quick way to tell what exactly can be done, what is the possible
That
result.
is without any destruction.
Destruction.
Yes, without any destruction. What you said, yes, is also done. But today, you know, even the customers, earlier we used to have those things, but nowadays even our customers are getting very bearing knowledge and failure analysis and all these things. And everybody is having the softwares also to simulate those things. And then they are only telling the DVPRs, the aisa karo, aisa karo. What we talk about RDSO testing and validation, it is there in auto segment also. Everything has to be done.
Is there anybody who wants to contribute something else in
Yeah,
this?
I think Bhatia sir was trying to ask some questions. Do you want to contribute anything to this?
I think actually I was just trying to touch upon the presentation was as given by by the Timken and the SCF team regarding your question was with respect to the high speed bearings. Your question was with respect to the high speed, how we are going to take care in the future with respect to high speed trains requirement. That was I would like to touch upon that the EN standard what we are talking about, na? That definitely take cares about the speed limit below 250 and above 250 also. It's have the inside of that also. Second topic, your minister you had touched upon the coating of the part. The coating point was that from the Upadhyay sir already discussed regarding the from the wind application point of view, and even from the railway point of view. I just like to just touch upon that part that we have they have not tried to cover in the presentation. Only I like to touch upon that the bearings what we are using for the railway application, either it will be a open type bearings or it will be a closed type bearings. The housings are of different types. So depending upon the application of the housings, if you the coating has been defined accordingly. If you freight car, normally we have the open type of the bearings. You can see even the bearing from the outside also in the and that time we have the specific coating with respect to the corrosion resistance. Coatings are already available and we are already implemented. I think all the manufacturers are already doing from the coating
it
point of
is
view.
phosphate coated.
Yeah,
All
that's
the
what-
bearings are phosphate.
So that's what so your question was with respect to the coating and this high speed requirement. So I thought I should give some insight for that also. With respect to your topic with respect to the high temperature, how we can take care with respect to the, I understand specifically he is focusing with respect to the more ball bearing type. I was just asked the question to you that normally we as a bearing manufacturer talk about the dimensional stability, the operating temperature. Okay, normally we talk about we even define this in our catalog also, that at which operating temperature and what is the stabilization temperature, we give the confirmation to the supplier, to the customer also, at which temperature our dimensional stability will not go away. So normally presently at what temperature you is been followed at your end? Are you aware about that? Which type of the temperature stabilization you expect from the manufacturer with respect to the, if we give the example S0, S1, 300. So this is the expectations what you have it from the. Where the 15-degree temperatures are what you are asking the cool. You have to just think about the cooling system only, not more than. Normally, even our catalogs, everyone speaks about the catalog.
I think in the presentation that I shown is the APT was something around 7. It means that the surrounding the bearing something like 800 degrees centigrade was. But the bearing temperature was like we are measuring it outer is 250. So it must be around 300 degrees max.
No, but we have some bearings. No, if you take in X-rays, so X-ray, no, inside there is a bearing. So that bearing goes up to 450 degrees. So we don't use any, lubricant. So we use, solid lubricant in that places.
Yeah.
Powders, we use. So, but those are all special, applications.
It doesn't act as coolant, they are only lubrication.
Yes,
Is the work
Yes,
of
it-
lubrication only.
but bearing itself is stabilized. See what we do when you give higher temperature, the heat treatment process changes so that the bearing will be stabilized, retaining the the accuracy, or the dimension at that temperature. So we change the heat treatment process like S1, S2, S3. So depending on your temperature, we change that process.
Sir,
Class of engine. Some people engines.
Yeah, truly speaking, at least we don't have any aircraft which is operating at 1500 degrees centigrade. It's not, but it is like our MCA, SHAMCA is like expected to operate at that temperature. Anyway, anybody from telco would like to highlight something related to automotive bearings and their recent developments? We're almost finished.
Yes, so you can join us on the stage. Yeah.
One person is left, you can join.
Yes.
I mean, that's what we are saying. We don't have any currently new developments that's going on in the bearings section right now. So it's we have been no new bearings. We are not using any new bearings from the this part.
Yes, any specific development in the steel sectors for bearings? Integrated steel plant?
Basically, so the endeavor is more on the wire rods, which is actually used for, making the rolling elements. Ideally, what is happening is that the rolling elements, which has been made as, especially the balls and the rollers I'm talking about, the small balls and the rollers, not the higher ones, where we use 86109 typically, the type of a grade. I'm talking about say 52100 grades actually. Here I have seen that actually that the wire rods are still imported from Ovako and Diado. We are not making that wire rods from here. So one thing is that the development which has to happen is actually that the wire rods which are for the rolling elements, that has to be developed here, because that involves some sort of a higher, probably some additional refining processes, which is not here, number one. As far as Tata Steel is concerned, we had actually acquired Usha Martin, as you know, all of us know. But in that sense also, obviously, the SAE 52100, they're in the process of making, they are already approved with Timken for some of the grades. But at the same time, SAE 52100, we are in the steel part of it. Some developments needs to happen in the upstream processing. It's still, I would say, there are players who are really good, like ISMT, Sunflag, who are there for the races part of it. But for the wire rods part of it, I think there is not a very established supplier in India. That is what, to the best of my knowledge.
Thank you.
Actually, now we are working on that front, because now most of our rollers are manufactured in Jamshedpur. So even for the global. So our supply chain team is working on that front.
Yeah, would you like to contribute something? Please introduce yourself.
I'm H.N. Shivshankar from L&T, Bangalore. Actually, we have been using rollers, bearings in our compactor applications, wheel loader applications. Okay, I just understood the current developments in the bearings. The discussion here was quite interesting, and some new knowledge with regard to the application of bearings. I have to go back and see where we can really apply this magnetic sort of bearings is what we need to explore. So I will be in touch with some of the dignitaries here, maybe to try and see the new kind of technology in our machineries. Thank you.
I think we had enough extensive discussions. I have identified 4 areas of possible documentation to begin with, which will be useful for all of us and also useful for BIS. The first thing is that I think we should try to identify what are the types of bearings and the material used in nuclear power plants or nuclear applications. We can make a small team, and this would not be a very exhaustive work. Have to start with 1 year time, followed by, as I was telling, that we should do the similar kind of exercise with aerospace grade. For the time being, railway bearings, unless
RDS
join us,
yes.
we would like to keep everything in abeyance. And possibly, as Professor Hirani was not there, I said we should also try to look for magnetic bearings for strategic applications only. We should just keep it commercial application aside, because it is going to be an expensive thing. It would be easier to justify for strategic applications, which includes space. We have to have people from aerospace, ISRO, atomic energy, and defense. For the timing, we take an estimated time of 1 year. Can be extended for 2 years also if situation demands, or depending on the progress.
Magnetic bearing conference, what you mentioned, we can write, if you have something in our mind, we can write initially review paper on that. It will give exposure on the BIS to them, and then maybe it will give also the kind of white document to the industry.
Yeah, if we can, if the manuscript can be made something of a technical paper and can be published in some decent journals, that's fine enough. Also, I think one more thing is missing. What are the journals we should try to subscribe? We have not really got enough feedback.
But I understand understand from my experience, soon all the journals will be online.
Open access.
Yeah, open access. Reason being, now even in IIT they will not get a fund for the journals, right? Which in most of the USA universities it has happened. So,
Even if they accept, they'll put it for 9 months, 10 months.
yeah, exactly. This is publication will be delayed by 6 months, 9 years, maybe sometime 2 years also, right? So
You have to, days are coming when you have to have paid publication.
yeah, paid publication, but keep a high impact factor and good review and all those things. That way. So in my view, that will be maybe we can do this time.
Open access journal is the future.
Yeah, right. Yes.
Thank you, sir. Okay, so are there any more questions? I think we are over with the discussions now. Right.
Yes, please.
Normally, the rotor system, we want to have a minimum running accuracies, like to have a lesser vibration. So we select rolling element bearings with a lesser radial clearance or the running accuracy, I would say. So for example, these high speed rotors or any rotating system with a rotating at more than 10,000 RPM, we prefer running accuracies close to 10 micron or 20 micron. So whereas in case of magnetic bearings, is it possible to have that kind of control to that levels?
Yeah, with the AMB, people have done already. Permanent magnet is a bit difficult.
Okay.
That's why in my speech also mentioned that when the real manufacturer come forward, it is possible.
Okay.
Rolling element has come because of the only industry participation. I don't think that academician or R&D lab can achieve this kind of business. So if there is a really maybe standards have been made in the manner.
Okay.
Sleeves are the kind of the compartmentalized. Only sleeve will be
Yes,
sold
yes.
by somebody. So those things are possible. In near future, it is possible.
Okay.
If you ask today, no.
Yes.
Right? AMB people have control up to 10 micron. As
Okay,
such,
sir.
there's no problem.
Okay,
Right?
sir.
And
Thank you, sir.
maybe I think Professor Tiwari wants to add anything because I know the 10 micron there's no problem because we have seen orbit with the electromagnet. Accuracy is possible. Now accuracy depends on the sensor accuracy.
Sensor, yes, sir,
If
yes.
sensor accuracy is bad, then things will be bad. Otherwise, number was some odd delay time. Whatever sensor response time comes, and then actuator has to really play immediate role in that. So if that delay time and that sensor response both are good, then there's no issue as such. So
Thank you,
you
sir.
want to add anything, sir? Professor?
Yeah, along with the magnetic bearing, always we have auxiliary bearing, which is having far less clearance, so that it should not strike the magnetic actuator, whether it's brittle. So in no case shaft should hit the actuator. It will hit the auxiliary bearing, which is rolling element bearing, with a larger clearance. It is not touching during the rotation, is free. But yeah, so
That is a clearance.
That will cause a more problem
Yeah.
for rolling element.
Yes, sir.
We don't want any touch should happen.
yeah.
Okay, sir. Okay, yes, sir.
Yeah.
Thank you, sir.
See, even for landing purpose, it will land on that particular bearing. So auxiliary bearing, yeah, and they are rolling element bearing.
In that case, instead of there's a rolling element bearing, I'll go with a permanent magnet. It will not touch at all.
Sir, thank you, everybody, for the interesting discussion session. Please have a big round of applause for our chairman and the speakers of the session. I will request Shri R.R. Singh, Head of Production and General Engineering Department, to felicitate the speakers of the second session with mementos. So, first, starting with I think Mr. Gururaj from SKF. Sir, please, speaker memento. Yeah. Next is Dr. Gonzalez from HAL.